Hi, Zach. Hi, Zach. Can you hear me? Zach, can you hear me? Hello, Zach. Can you hear me?
Yeah, I can hear you.
I can hear you. Okay. All right. Good. So, do you see a thing on the bottom which says share screen?
Uh-huh.
All right. So you can share your presentations, like the first slide.
Okay. And for the polling, can you do that whenever you'd like?
Yeah, I will. Here are a few questions. What type of blockchain is private, public, private? Okay. What does the? Okay. These are the. Oh, so you have three questions. Okay. What is Hyperledger? Okay, fine. So you have three polls. So I will start creating those polls, and then I'll just prod you that, hey Zach, can we do a poll now?
Okay. Or I could maybe jump in and say here's here's a good time for this question or whatever.
Yep.
Okay. Perfect. So I'll share my screen and then we can have everyone get started.
Yes. So I will just create those polls, and if you can just see that, right, launch poll. When I get all those questions, you can see the launch poll.
Oh, okay. Very good.
Yep. Hello. Yeah, I did start the webinar. Okay. Okay. Fine. Yep. Bye.
Is this good?
Yeah. This is perfect. So then, so we have participants. So how do I start? Interesting. So we have attendees. We have quite a few attendees already there, and how do I start it?
It may be started already. Can anyone hear?
Okay. So yes, Vishwa responded that you can hear.
Okay. So we can go ahead and get started if that's all right.
Okay. So yes, I'm able to hear. Perfect. All right. Sounds good. And
Okay, and you can go ahead and manage the chat and just let me know if I need to stop at any point.
I will.
Okay, is Anandita on the line?
No, I'll start it. She'll join as a later. All right, sounds good. Thanks. Good afternoon to everyone joining us on the webinar. So in a few minutes, we will get started. But first, let me cover some housekeeping item for today's webinar. So everybody who is joining today, except for the presenter, has been muted. So if you have a question, please ask it in the question window of the webinar. We'll try to get to every question individually or at the end. And if you have any problem on the screens not advancing or you are not able to hear properly, typically if you log out and log back into the webinar again, it fixes the problem. Okay. So thanks for registering for today's session. My name is Dhiman Bhattacharjee. I am the co-owner of Learner's Place Professional Academy, which is a leading provider of high quality training programs for working professionals seeking to enhance their skills and advancing their careers in the industry. And we are very fortunate to partner with Chainworks. So Chainworks is one of the world's first independent blockchain advisory, development, and B2B products and platform firm. It is leading the blockchain technology with a deep focus on innovation, whether through its internal innovation labs or co-innovating with its enterprise customers. Chainworks empowers blockchain for the enterprise through its Imagine, Create, and Operate service delivery model. And the title of today's session is Hyperledger Architecture Fundamentals and How It is Changing the Business World. And I'm really happy to be joined here today by Zach Golwitzer. So Zach is a full stack developer with a specialization in front-end frameworks such as Angular and React. He brings his vast understanding of user experience design to the blockchain industry. As an early adopter of blockchain technology, Zach has paved the way for others to follow with his extensive contributions to open source blockchain initiatives such as Hyperledger and Ethereum. In this nascent industry, intuitive user interfaces and appealing user experiences is crucial in facilitating mass adoption, and Zach has focused on just that. In Chainworks, Zach works primarily on enterprise blockchain client projects and Chainworks Innovation Lab initiatives while developing targeted blockchain training materials for various client workshops. When he's away from the command line interface, Zach has presented several talks on ICOs, cryptocurrency mining, and various other blockchain topics. So with this, I'm happy to hand this over to Zach, who will walk us through the Hyperledger architecture.
Thanks, Steven. So hope everyone is well today. I know we have several attendees on the West Coast. I'm right in the middle of America right now, so it's just after lunchtime, and I'd like to welcome you all to this webinar on Hyperledger architecture. So as Dhiman said, I'm one of the engineers at Chainworks, and the reason that I'm giving this presentation on the Hyperledger protocol is primarily because I've been working on this open source project for quite some time, have several insights that I'd like to share with you guys today, and also just kind of bring things all around and understand how this particular protocol and other protocols similar to it are changing the business world. So I will go ahead and take questions at the very end. I think we have 15 minutes allotted for that. And hopefully we'll get to all of them. And I might be able to actually do a few quizzes throughout the presentation if we can get that to work out fine. So I hope you guys enjoy, and I think you can probably listen up because there's a lot of good information coming to you now. So the first I want to, well, let's hopefully switch the slide first. We can do that. All right. So Hyperledger project, I'd first like to kind of describe what it is, because this presentation primarily deals with the Hyperledger Fabric and Hyperledger Composer sub-projects. So it's a little bit confusing to many people that have not worked with this technology to understand that Hyperledger is actually one big project under the Linux Foundation that has 10 sub-projects under its umbrella. So there's all sorts of different blockchain protocols that Hyperledger is implementing, and all of them are open source under the Apache license. At least I know Fabric and Composer are. You may have to fact check me on the others, but they're all open source in some way, which means for those that don't understand that term, anyone in the community can contribute to the projects. And that's been one of Chainworks' roles with the Hyperledger project, is we've actually devoted resources towards these code bases to make them more robust for everyone else using them. So that's the overall idea of what Hyperledger is. And going up one level, you have the Linux Foundation, which for any techies on the call right now, you are very aware of what the Linux Foundation is. But this is a large organization that has many, many projects, things like Red Hat under its wings. So it's a very esteemed project, the Hyperledger project is, and it's run by Brian Bellendorf, who has an extensive history in open source softwares for I think 20 plus years. I've met the guy, and he's awesome. Has a great mission for this particular project, and that's part of the reason that we're so on board with this. So that's enough for the background. Let's talk about Hyperledger Fabric, because that's what we're going to be focusing the majority of this presentation on. The reason being is the Fabric is arguably the most adopted project under the Hyperledger umbrella at this moment. There's over 300 global POCs happening on Hyperledger Fabric specifically. And then I will also kind of talk about Composer, which has something to do with Fabric that I will later reveal. So Fabric was first launched in 2015. It was not actually under Hyperledger's control or guidance back when it was first started, but they acquired, is not the correct word, but they brought this project on board sometime in 2016, I believe. And so this is actually a private and permission consortium blockchain. So if you have any idea what Bitcoin is, I hope you do by now, or Ethereum, we have to note that this particular architecture is quite different from those two public blockchains. So I want to give a very short overview of what Bitcoin and Ethereum are, because I know that's standard for every presentation that has anything to do with blockchain. I don't want to spend too much time on it, but just as a background, Bitcoin, as many of you know, was the first cryptocurrency that popped up in the mind share of the public, and it was very influential because it solved this problem that we call the double spend problem. So it basically allowed, in a nutshell, we previously were enabled to transfer data in an online fashion, but until Bitcoin came around, there was no reliable way to transfer real digital value over the internet. So that's the true innovation behind Bitcoin and other public protocols such as Ethereum. More specifically, Ethereum was kind of that second layer on top of the Bitcoin architecture, because Vitalik Buterin, love him or hate him, he kind of saw some pain points in Bitcoin's protocol. And the main pain point was the fact that developers could not really extend the platform. They couldn't build robust applications on top of the Bitcoin platform. So he basically created the innovation of Ethereum was the idea of the Ethereum virtual machine, which is something that allows you to write this thing called a smart contract on top of a public blockchain, which is the Ethereum blockchain, and those smart contracts will execute on the peers in the network. So that was the huge innovation of Ethereum. And so that's just the basics of the public blockchain space. But let me bring it back here to what we're talking about today. And this is a private and permission consortium blockchain. So the difference, in a nutshell, is a private and permission consortium blockchain is much more friendly to enterprises that can't necessarily put all of their identity management in the public domain. And it allows them to have a much more modular architecture that they can plug into. So with Hyperledger Fabric, that might play out in the identity management portion of it. So you can actually plug in whichever certificate authority that you'd like to use. That could be Global Sign or DigiCert or any of the other popular certificate authorities. You don't have to rely on a public blockchain that may or may not survive in the long term. So that's one of the key features of one of these private and permission consortium blockchains. And the way I think about it, before we get too far into the details of the fabric, is the private consortium blockchains just allows for this idea of triple entry accounting. So, one of the biggest innovations in finance was double entry bookkeeping. And it seems simple, trivial, mundane, but this was a huge innovation. And obviously, for those familiar, that you have the debits and the credits. Now, with these private permission consortium blockchains, it adds another layer. So you have triple entry. So not only do you have the debits and credits, but you also have a unique identifier for each of the transactions in the blockchain. So it's a very interesting concept. And although the private permission consortium blockchains don't have all of the benefits of a public blockchain, they do enable a much more efficient data processing environment within an enterprise. And also, along that point of efficiency, many of you know that the public blockchains actually had troubles processing high throughputs of transactions. I know this may be a kind of a far off example, but Ethereum recently saw this application called CryptoKitties, which sounds like a big joke, but what that showed us was the first popular application that launched on Ethereum actually crashed. I shouldn't say crashed, but clogged up the network to the point where transactions were not getting sent through. So a huge requirement for businesses is that cannot happen. And that is done through Hyperledger Fabric. You avoid that problem because the processing is very efficient. We segregate the consensus mechanism with the chain code execution. I know that's a mouthful to anyone that's not, a coder by day, but basically what that means is that instead of executing these smart contracts on every single node in the entire blockchain network, what we're doing is we're saying, okay, we're going to execute the chain code separately from the consensus, where like in Ethereum, what happens is each of the nodes in the network has to execute every line of the chain code and then provide that proof of work consensus. So this segregation of those two mechanisms lends to high efficiency of the network. So just like any blockchain, we do have similarities with the Fabric and public blockchains like Bitcoin. So we have node types just like any public blockchain. And in Fabric, there are actually 5 different node types. So first you have the membership service provider. So this is what I was talking about with like the DigiCert or Global Sign, the certificate authority. You have an ordering service node, which you can just think of as the maintainer of consensus, or as the name suggests, it orders the blocks out to the peers. So it keeps everything in order. And then you have the client, which you can think of, just envision, someone sitting behind a laptop in an office interacting with a application. That's all that a client is. Don't actually do any sort of consensus or validation on the network. Literally, a client just changes the state of the network. So then finally, we have the two types of peers. A normal peer still validates transactions, but what we'll focus on is the endorsing peer. An endorsing peer basically is one of those nodes that will execute the smart contracts or the chain code and figure out, is this a valid transaction? And we'll go into that a little bit later. Here's a visual of a sample consortium network. I'd like to point out that, or actually, let's go ahead and start with an example, because we'll get to this a little bit later in the presentation. So let's imagine that we have a perishable supply chain network. So organization 1 would be the grower or the farmer of the network. Say that particular organization is out in California. So they grow the perishable goods and will ship them out to organization 2, which is a shipper located, somewhere in the Midwest, maybe, maybe Kansas or something. Lots of distribution centers there. So you have organization 1, which is the grower out in California, organization 2 in Kansas, and then organization 3 might be out in, we'll say, North Carolina, and that is the importer. So you have these 3 different organizations that are all coming together in this consortium network on the Hyperledger fabric. And we'll go into specifics of what kind of things can be done in a business sense, but I'd like to first get through the fundamentals of the fabric itself. So the entire consortium network is set up through a Docker compose file, and basically a Docker is like a mini virtual machine, or if you're kind of a tech guy or gal, it's more of a process than a VM. But anyways, the entire network is just composed of a bunch of Docker containers. And so you can see on the screen, you have a certificate authority in each of these. You have peers, you have CouchDB, which is a state database, and then you have chain code containers. These are all running in individual Docker processes. Also, something to note is that you see that there is an OSN, or an ordering service node, running in organization 1, but not in 2 or 3. And that's a very important point, because you don't necessarily have to have an ordering service node for each organization. All this thing does is provide the ordering of the blocks, or the consensus of the network. And you can see it's kind of small in there, but you can see there's a little white rectangle in the OSN box, and that's the Genesis block. That block, unlike networks like Bitcoin, where the Genesis block is just like pretty much any other block, this Genesis block in a fabric network is very special because it has the entire configuration of the consortium network. It basically tells the other nodes like who to connect to and how to connect to them. So here's just a brief recap of what we just talked about. I'll run through it real quick. We're running everything in Docker containers. Each organization has 0, 1, or more ordering service nodes. You have 1 or more peers, a certificate authority, and a CouchDB state database. Or if you want to use the default, it would be LevelDB. And then finally, as we get into the Composer framework, you do have the option to run a REST server. So that's only enabled if you're on the Composer, if you're developing applications through Composer. And then finally, each organization is going to join 1 or more channels, and will designate 1 or more peers as like the anchor peers. So basically the anchor peers are the single peers of an organization that are designated as the connectors. So if organization 2 needs to connect to organization 1, they'll reach out to the anchor peer of organization 1. So I want to take you through a basic setup and the flow of a transaction in Hyperledger Fabric, because I think this this whole idea of a blockchain is very confusing to many people, and it's also a bit naive to say that all the blockchains work similarly. So I'll take you through how we're going to set up a Fabric network, and then how a transaction actually propagates through a life cycle that's very repeatable. So the first thing that we need to do is create a global channel. So we're assuming that everything has been set up on each organization's IT architecture. So we're assuming that the guy out in California, the one in Kansas, and the one in North Carolina, they have teams devoted to this. They've created the basic Docker containers needed to be a part of the network. So once that has been established, we can dedicate one of the organizations as the quote-unquote the consortium leader. So all that means is that organization 1 is going to be doing a lot of the administrative setup of this particular network, and that would kind of manifest in the sense of we need to create a global channel for the network. So that's what organization does first. So now that the channel has been created, all the peers will join with their certificates. So these are X509 grade certificates. That's kind of a term, you don't really need to understand it. So they'll connect with their certificates, and the peers will also use the anchor peer configuration that was created when the network was initially brought up to connect with the other organizations in the channel. So everyone's joining this global channel that we're going to be working with. Once that's happened, each organization's administrator installs the chain code that the consortium is running on their peers. This process does not impact any networking, as it is a local installation. So this is happening irrespective of each other. It doesn't have to happen at the same time. The only requirement is that the chain code that is being installed on each of the peers is the exact same chain code. So if organization 1 and 2 install version 1 of a chain code, and then organization 3 installs version 2, this will not work, and the network will never actually get started correctly. So that's very important. So there's only one organization required to instantiate the chain code once it has been installed on each of the peers. And when I say instantiate, it's basically maybe use another word such as invocate. In basically what it's doing is it's saying, okay, I want to initialize the chain code that everyone has installed on their peers. And the way that one organization, and as we'll remember, we designated that organization 1 out in California was going to be the kind of leader of this consortium. So they're going to be sending out the invocation transaction. And this is a special transaction that its sole purpose is to invocate or instantiate or initiate the chain code within the network. So now that we understand kind of how the network is set up on a very high level, I want to walk you through the steps that a transaction takes. So the life cycle of a transaction. And we'll use this invocation transaction as that example. So we'll say that we've got organization 1 employee who is out in California and is saying, okay, everyone's installed their chain code. We're ready to go. We can send out an invocation transaction to the network. So what they'll do is they'll log into their computer, and they will connect with their certificate to some sort of application. And that can be done through various SDKs or software development kits that are available for the Fabric. So they connect to their computer, probably pull up an interface, connect with their certificate, and press, some button that sends out that invocation transaction. So that transaction is then sent off to organization 1, 2, and 3 peers who are acting as the endorsing peers in the network. So you can see on the right side of the screen, I've just gone ahead and said that every peer is an endorsing peer. Easy enough. So this person out in California has pressed a button, we've instantiated, or we've sent the invocation transaction, and that's going to be sent out to every single peer. So we've got 2 peers sitting in, if I remember correctly, we should have 2 peers in California for organization 1. We have 2 peers in Kansas for organization 2, and we have 1 peer for, well, actually, you can see on the screen, we only have 1 for organization 1 and 2 for the other, respectively. So all of these peers are going to be receiving that transaction. So once these endorsing peers receive the transaction, they go through a pretty strict 4-step process to make sure everything is okay. So the first thing that they check is that the transaction is well formed. So in other words, is the data object that I'm receiving, does it match the syntactical requirements that my little peer has configured on its instance? So is it well formed? All right, so next up, has it been submitted in the past? This is the whole idea of replay protection. If you've kind of done your reading on Bitcoin, that's the whole idea of the double spend problem. We're making sure through the blockchain protocol that this has not been submitted in the past. So we're not able to send money to ourselves, basically. So number 3, we need to make sure that this invocation transaction has a signature on it, and that signature is the correct signature. So each organization has a certificate authority with the kind of the global crypto configuration. So in other words, every organization knows who the members of the consortium are, and so they'll check that X509 certificate and make sure, okay, this is coming from the right person. And then finally, step 4 is something that we'll kind of touch on for the business side of things. Is the identity that submitted this, is that identity permissioned or allowed to actually do this action? So for the instantiation or the invocation transaction, only administrators are allowed to do that. So these peers are basically checking, okay, is the guy from California who's sending this, is he an admin? And if so, we'll say, okay, it's good. So if it passes all 4 of these checks, they sign this, this particular transaction, they put their signature on it, and then they send it back to the original invocator of the transaction. So the employee from organization 1 out in California will receive some sort of data object or a blob that basically says on it, okay, all of your peers, all the endorsing peers signed it, you're all good. Now you can send this out to the ordering service. So that's what they'll do. They send it out to the ordering service, and then the ordering service goes through a few checks to make sure that everything is correct. And one of those checks is something called an endorsement policy. So what is an endorsement policy? Well, in the network, specifically in that Genesis block that we talked about, if we go back all the way to this slide, we can see that the organization 1 has an ordering service node with the Genesis block. In that block, we have a configuration that says, okay, we need maybe 3 out of 5 peer signatures for a transaction to be valid. So if that's the endorsement policy, then what the ordering service node is doing is it's checking that big piece of data that the org1 employee sent over to it, make sure that it meets the endorsement policy of 3 out of 5 signatures, and then finally we'll say, okay, all good, the signatures are met. Let's go ahead and propagate this particular transaction out to the peers. Okay, so the peers receive it. They do one final check to make sure the block transactions meet the endorsement policy again, and then they finally, this is very crucial, this is when the global state has been updated. So once these peers receive the AOK from the ordering service node, they're going to say, okay, I believe you, I trust you, we're going to update our own global state. And what that is doing is it's basically saying, if we go back to our diagram again, each of these CouchDB containers, that is the state database, and that is going to be what is updated and basically what keeps track of the blockchain itself. So I think before we get into Composer, we might go into a quick poll. So let me see if I can possibly get this going. Let's see. More. Is it a Q&A maybe? Dimon, do you have, is it your, do you have to do the poll? Oh, good, good. We got a poll going. Okay, so let's see what we got here. Dimon, how do we know if when it's completed?
So we know now that we have got 17 responses.
Oh, okay.
Out of 27.
Got it. I can't see that information. So
you can say, okay. So
you just let me know when it's over, and we'll kind of walk through the question itself and
okay,
kind of clear up some things.
So all right, so we have 20 responses so far, and let's just give a moment here, and then we will be.
I think this particular question or this particular moment might be good for all 3 of the polls, because they're kind of a recap of the session that we just completed.
Okay, good. So let's stop this first poll. The first poll was, what type of blockchain is Hyperledger Fabric? And then 77% of the respondents say that it's private permission consortium. Okay,
yep.
So which is the correct answer? That's good. Just a small percentage said that it is private, just 5%, and 18% said it's a public.
Got it. Okay, so this question was not necessarily supposed to be a tricky one, but I wanted to put it on there because it's something that we really need to distinguish when we're talking about different blockchains. Because as we kind of preach at Chainworks, different properties can be exploited from different types of blockchains. So with the private permission consortium chains, what we're saying there is that we have some identity management. That's the idea of the permissioned. We're in a consortium, so we're interacting with actually our business competitors or partners, and it's private in the sense that we're not exposing our transactions to the outside world. So as we talked about with that global channel that we created and joined all the peers to, this channel is only available to the identities that have been registered with the Hyperledger Fabric network. And the only way you can get registered is through the organizations that are setting it up. So, for example, the one out in California, Organization 1, who is the farmer, you know, I know this is probably not realistic that the grower or the farmer of the organization is going to be setting up this entire thing, but they're going to be the ones that are granting, you know, access to new members. And then once they've done that, then other organizations may or may not have the ability to register and enroll new organizations. So that's really the gist behind the private permissioned. For public, I think we're just getting confused with, like, that would be like a Bitcoin or an Ethereum. And the main difference between like a public and a private chain, or private permissioned for that matter, is the fact that anyone is able to join. So if I wanted to, it wouldn't be very smart of me because my computer doesn't have all that much memory. But if I wanted to take my laptop and download the entire Bitcoin blockchain, I could do that. I could literally just open up my Chrome browser, go to GitHub, which is where the code is hosted, download the code, and type a few commands into my terminal, and I'll be receiving all of the information from that chain. Now, with Hyperledger, with these private or private permission chains, we can't do that. You know, I can't just, you know, as some random guy living out in the middle of the country, I can't tap into this network that the California, Kansas, and North Carolina organizations have started. And then the last very subtle nuance between a private and a private permissioned is the idea that with a private, all we're really doing here is extracting that triple entry accounting principle for our organization. So this might have something to do with like internal master reference data management, that kind of thing. With a private permissioned, we're incorporating multiple organizations. So, you know, we're basically creating a network of companies that don't necessarily trust each other. So that's kind of the gist of that. So maybe we could do the next question.
Sure. So let's do the next one. All right, I've launched the poll.
And I think we'll probably, after we do the polls here, based on the time, I'll go briefly through what Hyperledger Composer is, and then we'll open it up for questions. So if anyone has questions regarding these polls, just kind of jot them down for a few minutes from now.
Okay, we are getting responses. Just give another moment till everybody finishes. All right, that's a minute. So let me end the poll and share the results. End the poll and share the results. So can you see the results?
Yep. So for you guys that put the none of the above, very good. That's a super tricky question. And the expectation was definitely the ordering service node. That would be what I would expect to see people answer. And the reason being is, you know, of course, the ordering service node is the one who is providing the consensus. So naturally, let's send it there. There's also an argument for the certificate authority, because we need to find out who sent the transaction. So that would be the role of the certificate authority. But the real answer is the peers themselves. So if I'm a peer, I'm interacting with the network like we had as the example, the guy out in California is connected to one of the peers, and they're going to send out the invocation transaction. And so that transaction is first going to all the other peers in the network. And so that's a little bit of a tricky question, but that's the idea behind a blockchain in the first place. We're getting independent consensus from each node in the network. So in other words, even though we're in a network with a bunch of people that we don't necessarily trust, we can be assured that each of those nodes in the network is independently verifying the transactions. So a little bit of a tricky question, but just wanted to put that out there so that we can point out those subtle nuances. So we can go to the last question then.
Okay, before I go to the last question, so there is a hand raised by Malay. So I am going to allow you to talk. Can you say your question while I launch the other poll? No, look like it's gone. Sorry. Okay, you have 15 more seconds to answer this question. All right, I'm going to end the poll now and share the result.
All right, that's good. So wanted to put this one up here, kind of a listening question, but well, that's interesting. I think that adds up to a lot more than 100%. Anyways, so endorsement policy is the only thing on here that's truly relevant to the fabric. Mining and proof of work, those kind of go hand in hand with public protocols such as Bitcoin or Ethereum. And then cryptocurrency, Bitcoin and Ethereum, they are cryptocurrencies. Now, with Hyperledger Fabric, we're not talking about, although you technically could create some sort of cryptocurrency on Hyperledger Fabric, what we're really trying to get at is a protocol that enables you to transfer digital value. So digital value could be anything from, a cryptocurrency, which is kind of, it's not necessarily something tangible, but you could also represent something extremely tangible, like in our example, a perishable network. You could represent a crop like corn. As that goes through the supply chain, you can represent that sort of value in a digital way. So that's the reason that I put these up here. Endorsement policy, not going to really go too much into that. That was just kind of the default answer. So so let me just quickly go through the final part of the presentation, because although it's not the focus, I wanted to at least touch on what Hyperledger Composer is, because I think it's very confusing, kind of the difference between Fabric and Composer. And so basically my answer to that is Composer is kind of like the WordPress for Hyperledger Fabric. So if anyone's familiar with WordPress, it allows you to basically create a website without ever writing a single line of code. So it's kind of a far off example because you do have to write code for Hyperledger Composer, but what it does is it makes the process a whole lot easier. It allows you to write code just like you would any sort of web application, but it applies to a blockchain network. So, and that would be Fabric. So that's the linkage between the two. Composer is an abstraction on top of Hyperledger Fabric. So I think we're probably about ready for the Q&A. So I'll leave it at that, and then we'll see kind of what questions everyone has.
So there's already a question there, Zach. I don't know if you can see that. What's the need for an OSN? Why not have the transaction broadcasted directly to the state channel once verified by the peers?
Okay. So yeah, I don't see the questions. Maybe I could pull it up or something. Oh, Q&A. I'll just have you.
Okay, I'll just read those questions.
Yeah, that's fine. Okay, so the question was, why don't you just send from, if I get this right.
What is the need for an OSN? Why not have the transaction broadcasted directly to the state channel once verified by the peers?
Okay, so the peers verify it, they put their signatures on it, and you're asking, why don't we just commit that to the global state right then and there and skip the ordering service completely? So my answer to that would be it's all about, I mean, I know it's kind of redundant to say this, but it's all about ordering the blocks. So if that was the case, then these transactions in blocks in a very busy network with lots of transactions would be delivered to each of the peers in the wrong order. So if you have one transaction that basically says, okay, I want to create a new shipment of corn, and the quantity is 100. So that'll be sent out, and we'll say you skip the ordering service, but at the same time, another person said, I want to delete that particular shipment of corn. So depending on the network latency, certain peers are going to be receiving that at different times and may or may not commit the right state to the database. So the ordering service basically latches on to this idea known in CouchDB, such as it's the change feed or the revision history. So it's kind of a more of a technical concept, but that's the gist of it.
Perfect. Thank you. So there are more questions here. So one of the participants is asking, can you provide a chain code example?
Yeah. So yeah, let me go ahead and just pull something up real quick. So this is Composer, and this is the framework I just talked about. In this particular network, this is the model of the perishable network that we were talking about. So we have the grower, the importer, and the shipper. So a particular example of chain code would be something like a temperature reading. So we just populated this with some sample contracts and shipments. And so we have the shipment 001, which is a shipment of bananas in a quantity of 5,000. Okay, so this is going to be propagating through the supply chain. And what we would like to have happen is different participants, so say the importer or the shipper is going to put a temperature reading on the bananas. And if that temperature reading is outside the bounds that was set on our contract, so right here it says minimum and maximum temperature. If we say put a temperature reading of it's 12 degrees Celsius, that would basically mean, okay, it's outside of the range, and what will happen is the smart contract will execute and it will deduct the price that the grower receives for that shipment of bananas. So that would just look like this is a nice little playground that you can do, or you can use. And what we're not doing shipment received, we're doing temperature reading, and we're going to put it on shipment 001, and we'll give it a temperature reading of, like 14 or whatever. So we submit that, and then we go to the shipment, and you can see that we now have a temperature reading on it. And the smart contract, when we click receive transaction, will actually deduct a penalty factor. So if we've got an importer, we probably need to change the account balance here so that we have some money to work with. But the idea is that the grower is the one that's making the money. And since we have an account balance of 0, we're going to get an increase of account balance that is comparable to the unit price times the quantity minus the penalty for having too high of a temperature. So we submit the transaction, shipment received. Okay, so now the farmer has an account balance of 500. So I'm not going to do the math, but that's a basic example of what chain code or a smart contract might do.
Good, thank you. So there is a similar example or similar question, right? Can you please share a few examples or more examples of where you can use Hyperledger in a corporate world?
Yeah, so I think there's many answers that you could probably get for that question. I'm going to kind of gravitate towards a very specific use case, and it has to do with this perishable network. So I think that at Chainworks, we've kind of started to see that a major use case for a consortium network is any supply chain. So it doesn't necessarily have to be a perishable network where you're shipping food. It could be anything, but anytime we have multiple parties that don't necessarily trust each other, and we're transferring some sort of value across across participants, that's always a pretty good use case for this kind of network, because it just makes the whole process more transparent and efficient. Another use case, you could actually go more towards, I know this fabric is particularly geared towards the consortium networks, so the private permission consortium chain, but you could also write it for just a private chain. So if you really wanted to, you could map out your own organization and say, like, okay, we've got 4 lines of businesses that don't necessarily talk to each other very well. And so you could use this sort of framework as a way to keep control and manage the data that's flowing throughout your organization.
Good, thank you. So related question here. So certificate authority can be any CA signed already used in enterprise. Is that correct? Like, can Kerberos be used for authentication layer, or there are no such concept?
Yes. So that's that was kind of going back to the idea of how pluggable the Hyperledger fabric is. You can set up any customized membership service provider. The only requirement is that you're using the right certificate protocol. So, or at least your standard across the entire consortium. What like for example, X509 certificates.
Okay, good. So then there is another question. Are there tools that can deploy a local Hyperledger fabric on the laptop, like for testing?
Yeah, so I could actually maybe show an example of that. So right now I have a bunch of Docker containers running, and you can see it's kind of messy on the screen, but this is a local Hyperledger Fabric network that's running that we at Chainworks kind of are able to use as a testing ground for developing solutions on top of it.
Good. Okay, so that's good. So then there is another question is, what is the best way to get started learning how to interact with Fabric? Is it through Playground, or would you recommend something?
Yeah, so I would, unless you're fluent writing Golang, actually they also, I think you can write JavaScript smart contracts as well now in version 1.1. But if you're writing native chain code, by that I mean you're skipping Composer as a framework completely. It can get pretty tedious. There's a lot of pieces that move around in this sort of deployment. So a definitely a starting point would be Composer, and I would urge people to check out the Composer Playground, because it's pre-built with bunches of sample networks, so you can see sort of how this could possibly work in different scenarios, and you can play around with those networks. So I would definitely say Composer, and then they have lots of good documentation for developers as well.
Perfect, thank you. And then one last question, we don't have much time left. Maybe one other question. So the question was that, does Hadoop related technologies fit in Hyperledger Fabric anyway? I mean, if you can answer that.
There's not an inherent link, but of course, with any protocol, there's inputs and outputs. So these networks, you can program them to basically emit different events from the network. So of course that'd be a way that you could connect to some sort of Hadoop instance. But within the actual fabric, there's no particular space for that kind of thing.
All right, that's good. So that's all we had time for the questions. So if you can go back.
Yeah, we'll go back to the slide.
And share the upcoming workshop that we are having. And this is on July 13th and 14th, which is a Friday and a Saturday. 2 full days of hands-on workshop from blockchain concept implementations. It is in the Silicon Valley Technology Innovation Club, which is in Scott Boulevard in Santa Clara. And you can get more information in this website, lpconventions.com. It's again lpconventions.com, and we'll also send you an email should you have any follow-up questions. And if you are going to register within June 15th, we are also giving out a 40% discount on the workshop. So that's a good way of looking at it. This workshop is done with joint collaboration of Chainworks along with Learner's Place. Our media partners is ICO Holder, and then the sales partner is Silicon Valley Technology Innovation Club. And we are holding that conference in Silicon Valley Technology Innovation Club, which is in the Scott Boulevard. So again, any questions, please feel free to reach out. And otherwise, thank you so much for. There will be hands-on. Yes, the hands-on will be the entire day of hands-on in that workshop. So the first day would be concepts. The second day would be application of that concept. So that's all hands-on on that workshop. So thank you, whoever asked that question. So yes, so that's it. So the conference has been recorded. If you are interested specifically, ask for it, and we'll be happy to share the recording with you. Otherwise, hopefully it was helpful, and hope to see you in the conference in July. Thanks, everybody.